Hey there, grade sevens. Welcome back. This is going to be lesson 7.6, and we're going to be talking about tree diagrams. So before we get into tree diagrams, there's an important kind of word that you need to understand. And what that word is called an independent event. So an independent event is when you have multiple things that are happening, but the outcome of one is not having an impact on the other event. So for example, I have this dice. I roll my dice, I get a 2, okay? If I roll it again, because I got a 2, the fact that I got a 2 does not impact the likelihood of me rolling a 2 again, okay? So I roll it again, I got a 1, all right? Every single time I roll the dice, my odds were 1 in 6. Now, when it's not an independent event, so say I take all of my dice, all right? I close my eyes, I grab one, okay? I don't know which one it is, but I don't return it, okay? Now, now I have 5 dice. I did have 6, now I have 5. I close my eyes again, I mix them up, I grab another dice. The chances of me grabbing this dice became better, okay? It was 1 out of 6, then it was 1 out of 5. So I do it again. I remove that dice. Now I have 4 dice left. So the chances of me grabbing any particular die is 1 out of 4. Okay? When I started, it was 1 out of 6. So the odds of a particular dice getting selected were less. All right? So now I have the 4 dice. I close my eyes. Okay, I grab one. I grab the black. Now it's down to 1 out of 3. These are called dependent events, where the outcome impacts the likelihood of something else happening. So for this example, we're talking about independent events. So if I roll a dice, I roll another dice, I roll it again, the likelihood of whatever's going to show up is not changing. All right, so when we're talking about independent events, it's something where the odds are always the same. So if you're rolling a dice, if you're rolling a 6-sided die, it's 1 out of 6 every single time. That it's not going to suddenly change. Just because I rolled a 3 and I roll it again doesn't mean I have a less chance of rolling a 3 again. Okay, it's still 1 out of 6. So now what we're actually going to do is we're actually going to develop what's called a tree diagram. I'm going to start with something really basic. So let's say we have 2 coins, okay? Or we have 1 coin, but we're flipping it twice. So we're going to say we have flip 1, and then we have flip 2, and then the totals, okay? So if we flip it the first time, we have 2 possible outcomes. We have heads, okay, so that's represented by the H, and we have tails, which is represented by the T. So after I flip it, whatever happens after is completely not dependent on what happened in the first time. So I flipped the coin once, and now I'm going to flip it a second time. So what can I possibly get? Well, I could get heads again, or I could get tails. If I flip tails the first time, what could I get? Well, I could get heads, or I could get tails when I flip it the second time. So my total possible outcomes can go heads, 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 tails, tails, heads, or tails, tails. So we can actually kind of break it down, and we can put it into a chart if we want. So if we had flip 1, flip 2, okay, it might look something like this. So we had heads and tails as possibles, and we have heads and tails here also as possibles. So what would we get? Well, we have heads and then heads, or we could have heads and then tails. We could have tails then heads, or we could have tails and then tails. So kind of when I'm going through this, what I'm seeing is I'm getting kind of the same possible outcomes here as I am here, okay? So when I have something like this, I can ask questions, and this is a little bit more grade 8, but I can ask a question like, how many total outcomes are there? Well, when I look at this, I've got 1, 2, 3, 4. When I look at this, I have 1, 2, 3, and 4. So similar to what I did last time. So I could say, what's the possibility, if you flip a coin twice, that you will get heads at least once? Well, of the 4 possible outcomes, heads shows up in 3 of the 4 outcomes. In this case, it happened twice, but I just want it to flip once. So that would be 3 out of 4, okay? Or 75%. What's the possibility of heads being flipped twice? Okay, what's that both of them, so I would have a 25% chance. So 1 of the 4. All right. I'm going to switch over to this one. We're going to do another one. So we've got a spinner here, and we've got red, blue, and green. And then we're also going to have a coin, and the coin can be heads or tails. All right. So this is what we're going to do. So we're going to flip the coin. So we're going to do coin. Coin, we can get heads or we can get tails. Okay. And then we're going to spin the spinner. Okay. These are independent events. Just because I flip heads doesn't mean I have a better chance of getting green. I'm assuming that all of these are equal probability as well. So what are my possible outcomes after I've done my first event? Well, I could get red, I could get green, or I could get blue. And then if I hit tails, I could get red, I could get green, or I could get blue. Okay, now what are my outcomes? I could get heads red, heads green, heads blue. Or I could get tails red, tails green, or tails blue. Okay. How many total outcomes are there? Well, 1, 2, 3, 4, 5, 6. There's 6 total outcomes. What's another way I could calculate that? What are the total outcomes from my coin? Well, I have heads and tails. I have 2. What are my total outcomes with my spinner? I have red, green, and blue, so 3. I can multiply them together to get 6. All right, so that can tell me how many total outcomes I might have. And then you're looking at what are the favorable outcomes. What are the odds that I flip a heads? Well, it's going to be 50% because half of them have heads. The other half have tails. So it's basically saying whatever happens with the spinner doesn't really matter. Okay, what are the odds that a blue comes up? Well, I have a blue here and a blue here. So 2 out of 6, so 33%. All right. So your main lesson is drawing the tree diagram, and I kind of went a little bit further than I probably needed to, but just to kind of give you a better understanding of why it is we're doing what we're doing. Okay. If you have any questions, make sure that you bring them to the Zoom chat. Make sure that you complete your Google form and your math makes sense. Good luck, everyone.